And it is something then that you can imagine, you can ask, can a very advanced civilization manipulate vacuum fluctuations adequately in order to make enough exotic matter inside a wormhole to hold the wormhole open? And so I posed this as a question to my physicist colleagues, stimulated by Carl Sagan and him wanting to send his heroin through a black hole. I said, no, use a wormhole. And so we got to hold it open. And so physicist colleagues, please help Carl and figure out, can an advanced civilization do this? And the answer is we still don't know. 40 years later now, we still don't know.
So why, if the vacuum itself can dip below zero and bend space-time in our favor for an instant, can't any amount of intelligence and technology turn that flicker into a stable doorway between distant stars? We often treat emptiness as absence, but physics has never granted us that luxury. The vacuum seethes with fluctuations, restless correlations in quantum fields that can nudge measurable energy densities up or down, a picture often summarized with virtual particles as a calculational shorthand rather than literal stuff popping in and out of existence. In exquisitely controlled experiments, we've pushed plates together and found a measurable tug from nothing. The Casimir effect, a pocket where the energy density is lower than the surrounding vacuum. If negative energy is not a fantasy but a laboratory fact, then a daring mind asks, why not scale it up until space-time itself yields a shortcut? The promise is intoxicating. But the moment you lean into that promise, you run headlong into a toll booth operated by the quantum. The laws that allow a dip below zero don't permit endless overdrafts. Quantum field theory enforces constraints on how much negative energy you can have, for how long, and how tightly you can focus it. These are not bureaucratic regulations. They fall out of the uncertainty principle and the stability of the vacuum. In the 1990s, physicists derived quantum inequalities that act like an accounting ledger. They bound how negative the time-averaged energy density can be over a given duration and region, and in many setups, a negative pulse must be accompanied by compensating positive energy with stricter limits the longer you try to delay that payback. It's like borrowing from a lender who demands repayment with interest on a clock you don't control. That curbs the dream of an indefinitely propped open portal. You might gleam a tiny opening for a tiny time, only to see a compensating surge of ordinary energy slam it shut. Progress. Yes, negative energy exists, but the deeper implication is that nature attaches a timer and a credit limit to every attempt to weaponize it. Even if you could push those limits, space-time itself fights back through feedback. Imagine light approaching the throat of a would-be wormhole. The geometry can funnel and blue-shift that radiation, amplifying the energy density right where you're desperate to keep things delicate. Small imperfections cascade, and semi-classical calculations show stress energy can diverge when you try to construct paths that would let you circle back in time. That's not a moral objection. It's a dynamical one. Try to turn a shortcut into a time machine by moving the mouths around, and the vacuum polarization spikes, threatening to blast the configuration apart before paradoxes are born. It's as if consistency is not imposed from outside but enforced locally by the zero-point jitters of the fields themselves. You can glimpse a pattern. Every route that looks like a free lunch ends up generating a bill in the currency of instability. So perhaps the premise, pack space-time with exotic stuff until a tunnel stays open, is the wrong lens. In the last decade, a turn in our understanding has pointed to something subtler. Consider the idea that quantum entanglement is not a decoration on top of space-time, but a scaffold of it. Two systems can be maximally entangled and yet lie worlds apart. Their joint state carries correlations no classical story can mimic. Build that up across many degrees of freedom, and you don't just store information, you may knit geometry. A bold conjecture even equates certain quantum entanglement structures with wormhole connections. In toy universes where calculations are tractable, researchers found that by creating a precise coupling between two entangled black holes, a pulse of negative energy can be arranged to travel through the interior, making the bridge traversable, briefly and without violating causality. Information can be transferred in a way operationally akin to quantum teleportation, and no message outruns light. The setup demands pre-established entanglement plus a causal interaction or classical communication to open the root. Suddenly, exotic matter looks less like a magic fluid and more like a carefully choreographed pattern of correlations. That reframing changes the target for any advanced civilization. The question is no longer, can you shovel enough negative mass into a throat? It becomes, can you manufacture, maintain, and steer astronomical entanglement while the universe's own noise tries to tear it apart? Decoherence, and the tendency of quantum systems to leak information into their environment, is relentless. Any practical bridge built from entanglement would require error correction on a near-cosmic scale, aligning quantum phases the way you'd phase lock 1,000,000 violins in a hurricane. The prize, however, is not a free pass around causality. At best, such a wormhole acts like a secure courier, a channel whose capacity and timing are limited by the quantum bookkeeping that created it. You can't send something you haven't coordinated for, and you can't copy its contents without wrecking the channel, because duplication of unknown quantum states is forbidden. The very features that let the bridge exist prevent it from becoming a paradox factory. There's an irony here worth savoring. We began by wishing for a material that would hold space-time open like a propped door. We end up confronting the possibility that the material is information itself. Geometry becomes the visible footprint of invisible correlations, and several of the traditional energy conditions, the rules that tell matter how to curve space, find quantum counterparts tied to entanglement, such as the quantum null energy condition, which constrains how correlations can be distributed. When the accountant says you're out of balance, the universe doesn't scold you, it floods the region with radiation, or it scrambles your careful quantum state, or it tightens the inequalities until your negative energy trick evaporates. Consistency emerges not as a guardrail, but as a constitutive property of reality. This isn't a no stamped on curiosity, it's a yes, but only if your ambitions align with the ledger, and that returns us to the nagging question. If vacuum fluctuations can briefly go our way, if mathematics admits geometries that look like tunnels, if even laboratory analogs hint that teleportation and wormholes might be two faces of the same coin, why can't a supreme technology simply scale it all up and fly through? Because the path to a stable, traversable bridge is not blocked by lack of power. It's bounded by the same principles that keep the vacuum from exploding. Negative energy is real, but rationed by inequalities that grow stricter as you demand size and duration. Space-time reacts to shortcuts with amplifying instabilities that preserve causality. And one of the most concrete loopholes we've glimpsed replaces exotic matter with engineered entanglement and controlled couplings, turning a highway into a carefully timed message tube whose capacity is bounded by quantum information limits, not brute force. So the answer is, you can't hold a doorway open by muscling the vacuum. You can, in principle, thread a needle with correlations. Until a civilization can program the quantum state of spacetime across astronomical distances and accept that such bridges serve consistency rather than defy it, their portals will flicker and fail. The universe isn't withholding. It's balance in the books, and geometry, in the end, is the accountant. Like if this was interesting, and hit the subscribe for more.